Okay, how you going, guys? Tuesday, 18th of May 2021, and it's just coming up on 12 o'clock, a little after 11:30. And this is just a little job we're doing for a builder. Dave's Dave, nice guy. And we've got to replace all this timber. Okay, all that with steel beams. And we've got some more steel beams on that one there. This one here. So there's all those steel beams there going in, which is more than what's on the engineering. Just to let you know, we did have a problem with engineering on this job. Okay, it comes down to experience. I've dealt with many engineers over time, and today almost everything has to be engineered, which none of this here was. None of this you see here, all these steel posts, the concrete posts, the timber beams, none of that was engineered. It's just what somebody put in. Okay, 100 years ago, or even when they were 100 years ago, this was all on timber posts. In the last 20 years, it's been put on concrete posts, and they put some 100 by 100 steel posts. Whoever came up with that idea. Okay, yeah, it's nice to have the big post, but it didn't need to be anywhere near that big. Very hard to build in. So what we've got happening, Dave's got a new concrete floor going down over the top of this. We've got to take these stumps out. That stump there gets replaced with a 75 by 75 by 5. Now the engineer we had on this job, in his infinite wisdom, from what I could figure out, looked at these timber and thought, oh shit, what are we going to do? We've got to match the strength of that timber. But that timber's not doing anything except holding up the floor. It's just some timber that somebody had available and decided, okay, it's a good idea to throw in here. It's definitely strong enough. Well and truly, you can park a Mack truck up there. Well and truly strong enough. Okay, but it has nothing to do with engineering. The total load weight right there at that point is a maximum of 3 ton. Maximum. Probably only 2. Because floor weight only. There's no walls up there. No load bearing walls whatsoever in this house internally. Because the way it was designed, everything's done on the outside walls. And the roof is pitched off the outside walls. It is not loaded. It's all on rafters. And it's all the weights on the outside walls, which was the outside stumps there, and there's a stump every 2 meters. Okay, so no weight internally. Each stump, this whole house weighs probably 36 ton when it's wet. And there's 36, 40 stumps under it. So there's no more, and I mean no more than 1 ton per stump of weight on this house, on these stumps. So 100 by 100 by 4 mil is well and truly overkill. 200 by 200 concrete is overkill, but that's what we do. We would do concrete stumps at 200 by 200 or 180, whatever they are, and they're well and truly strong enough to handle the load. Okay, these beams, which are able to handle many ton, are just what somebody put in here, because there would have been a stump here. Of course, it's secured over there to that stump, and there would have been a stump in the middle. And they've replaced it by taking that stump out, putting this big beam across here, which they've done 2 pieces of timber. Way over. Okay, this one's Oregon, but it's 120 mil wide. And then it's got this 70 mil wide piece of hardwood next to it. That's, if you're looking at engineering, that thing's able to handle a truck. All right, you can hang a truck off it or park it on top. All right, so there's no problem. It's able to handle many ton on that joint. Not just the 3 ton that's possibly there. So we had a problem with this engineer thinking, like he wanted this beam is only 4.5 meters long. Now in almost any sense of the word, to do what we're doing is going to be a 230 PFC. Okay, to go through there with another 150 coming into it welded on either side. Maybe 180 on that side. So it's 4.5 meters. But he wanted, he had a 250 UV, a light one through there, which I'm happy with, that's good. We got a 250 going back. We did what he wanted. We got 200 PFCs, well he wanted 200 UVs, and I changed them to PFCs, which he wasn't happy with. Even though the PFC's heavier than the UV. And you've just got to watch out, just because they're engineers and have all these weird and wonderful letters after their name, okay, or before their name, does not mean they actually know what they're doing. Okay, they are advisors, and you are allowed to question them. Quite a few of them don't like the idea that somebody might be able to question them, but you are allowed to do it, especially if you're the one paying the bill. Okay, so we had a query. I started questioning. The builder was a bit sus as to why everything's so big. I was definitely suspicious as to why everything was designed. Like he wanted he came up with his second design. This post here was to be replaced by a 200 by 100 by 8 mil steel post. That handles 150 ton for that size. It's only going to handle 3 ton. That's all it needs to handle. You know, so I have no idea what he was thinking. I really don't. So after a discussion with him, he mentioned that it might be an idea that we change the engineer. So I said, okay. And we got another one in. And the other one's quite happy with what we're doing. He knows that what we're doing is overkill because we're using the other engineers, the first engineer's steel, because that's what I bought, the 200s, 200 PFCs. So it's virtually his design. We've just extended it by going a few barriers further, and well and truly oversized. So we're well and truly in our in the realm of decency for these steels for the weight they're taking. So no problem at all. Well, that's what we're doing. We're going to fit those steel beams up to those barriers, start tomorrow. Got some stumps to come out. The builder's got all this to dig out over here. Retainer wall goes past that pipe there. There's a retainer wall going there straight through. As all this gets built in, a new floor over the top of this one. And yeah, that's where we're at. That's what we're doing. I'll take some more video as we go on. We're going out to this room here. The retainer wall actually goes past through the middle here, across here, steps over, and then through there, up through there. So we've got to replace these 2 concrete posts with steel. That one turns into a steel post. This one here comes out. That one over there comes out. Apparently we've got 2 steel posts to go in here where these 2 concrete ones are. So yeah, a little bit of fun as we get the steel in, so it makes it easier for the excavator, because some parts of this are just a little low for them, for a mini excavator. And that's what we're going to be doing for Dave. And tomorrow and the day after we should have all that steel in. This will keep us busy for the 2 days. Okay, we'll catch you guys again soon. Okay, great that you made your way here. Please, hit that like button and subscribe if you would. That'd be much appreciated, as we are still building the channel, and we'll continue to do so. It's 11 years old now, and very few people on, because we're doing a very limited job. It's stumping. House re-stumping is virtually 95% of the world house re-stumping is in Australia, mostly in Queensland. Very few places around the world actually do it. A couple of the islands, maybe out on some of the resorts, but for houses, no, most of it's southeast Queensland, North Queensland, yeah, that's about it. Down south, New South Wales, Victoria, the southern states, very rare to have houses on stumps. Alright guys, thank you very much, and we'll see you again shortly. Bye.